Hello, this is Mrs. Pullen for AP Statistics Lesson 2.04. In this video, I'm going to show you how to find areas under a normal curve using the standard normal table, which is in your reference sheet, the yellow packet that I gave you. So yesterday's lesson 2.03, we found areas under a normal curve using the empirical rule. Specifically, if you were looking between one standard deviation, 68% of the data would lie there. If you were looking between two standard deviations, that was 95% of the data. And if you were looking between three standard deviations, that was 99.7% of your data observations. But what happens when your data value doesn't land on, a whole number? One, we could use the standard normal table, which is what this lesson is about. And the lesson 2.05, I'm going to show you how you can use either the Inspire calculator or Desmos to get the same answer. It's important to learn how to use the standard normal table because some of the types of questions that are asked, having that knowledge is helpful. So what is the standard normal distribution? It's a distribution which has been standardized, meaning that you're calculating z-scores for each data value. Therefore, the mean is going to be now 0 and the standard deviation is 1. The shorthand notation for a standard normal model is capital N, standing for normal distribution. The first, whatever's in the first position of that parenthesis is your mean, and with whatever's in the second position is your standard deviation. The standard normal model always has a mean of 0 and a standard deviation of 1 because it's a z-score, it's a standardized score. So the best way of understanding how this works is by doing a problem. So we want to find the proportion of observations from a standard normal model that tells us it's been standardized and the mean is 0 and the standard deviation 1 that are less than 0.81. So for your work, you're always, even with a calculator, going to have to draw a bell curve or normal curve with proper shading. So I would always put the mean. The mean is 0. The value we're looking for is 0.81, and you're required to shade. And so I'm going to shade to the left then because it says less than. Notice that we could not use the normal, the empirical rule because 0.81 is less than that complete standard deviation. So we would refer to table A. So if you go to your reference sheet, that yellow packet that I gave, and you scroll down to table page 4, the fourth page, or I think on the bottom it says 261, that's the first page of the table, and it goes from pages 4 to 7. And notice that you have your z-scores on the left margin. Notice that it goes to the nearest tenth, and I'm going to show you how you can get a more exact figure by looking across. But again, the best way of showing it is with an example. So I'm trying to find the probability. It's not an x value anymore. It's a z value. It's a z-score because it's a standard normal curve. So we want the z-score is less than 0.81. So what you're going to do is find where 0.8 is, and then that is only to the nearest tenth. If I want to the nearest hundredth, you're going to go horizontally across the row and then look at the heading to find the hundredths place. So 0.81 is going to be 0.7910. Now that's just in your notes. In an actual table, you would keep on scrolling down. And you see here's 0.8, and then 0.81 is 0.790. And you can even see the diagram. The percentage is always, or the proportion of values is always towards the left of whatever the cutoff is. So this is really important. The table entry for Z is always the area under the curve to the left of Z. Okay, so how do I do this in a word problem? Let's go to example 2. After accelerating for 20 seconds, the DeLorean sports car, that's from Back to the Future, has a wide range of speeds that it can achieve depending on traction. The distribution of speeds follows an approximately normal distribution, so that's really important. You have to know that your data follows this normal distribution with a mean of 80 and a standard deviation of 7.7. So right now, this is an X value. The scores have not been standardized. I know this because they gave me a mean of 80 instead of 0 and a standard deviation other than 1. It still works like the first position represents the mean and the second one represents the standard deviation. Okay, so the first thing they want you to do is label the curve. Now, I already did that to save time in the video, but what you would do is you would put the mean of 80 at 0. You would keep on adding 7.7 to get the speeds at 1 standard deviation, 2 standard deviations, and 3 standard deviations above. So 80 plus 7.7 is 87.7, another 7.7 is 95.4, and so forth. To get 1 below, you're going to take that mean and subtract 1 standard deviation. So 80 minus 7.7 is 72.3. Another 7.7 gives you 64.6. That's what they mean by that. Okay, so part B, what percentage of runs will give the DeLorean a speed less than 68.45? Well, 68.45 is between -1 and -2. So I can't use the empirical rule here because that data value is in between -1 and -2 standard deviations. So what are we going to do? I'm going to show you. Well, no matter what, you're always going to draw your normal curve as part of your work. For the purposes of a lesson, to speed the lesson up, I included the drawing. The mean is going to be 80, and we're looking at speeds of less than 68.45 miles per hour. And now we're going to shade. You always have to shade. So one thing you'll have to get used to is probability notation. Oh, I have the wrong thing up. Hold on, let me get the marking pen. So we want to find the probability that a particular random run from the DeLorean has a speed less than 68.45. So when you're using table A, you're going to first have to convert it into a z-score. The z-score formula is the data value minus the mean over standard deviation. And as we discussed before, that's something you're going to have to memorize. So z is equal to 68.45 minus 80 over the standard deviation of 7.7. And when you put that in your calculator, you're going to get -1.5. Okay, so we just converted our speed into a z-score, and so we're finding the probability now that the z-score is less than -1.5. Okay, so how do I do that? I now go to table A. Again, tomorrow you'll learn to use the calculator, and 1.5. Oh, it's -1.5. I think I just, okay, so I go to -1.5, and that's on page 1, and it's -1.50, so you go to -1.5, and we're going to look at this column, and there's the 0.0668. Again, you're always looking at that area to the left. So this is equal to 0.0668. Now, they ask for the percentage, so because they ask for the percentage, you're going to multiply this 0.0668 by 100 to get 6.68%. If they didn't ask for it, you would leave it as a proportion. Okay, so now we're going on to part C. What percentage of runs will give the DeLorean a speed greater than 85 miles an hour? And we see again that 85, can I use the empirical rule? No, because the values are in between 0 and 1. Even if it was exact, you can always use table A or technology. You don't have to use the empirical rule. Okay, so you're always going to draw your normal curve. That's part of the work that's expected on the AP exam and on my test. We want to look for greater than 85. And so we're going to shade in, you must shade in your diagram. And let me get my marking pen out again and write the notation. So we want probability, or X, a random data value or a random run, is greater than 85 miles per hour. I know I'm going to have to convert that to a z-score using the z-score formula, which again you need to memorize no matter what. So when I plug in, I get 85 minus 80 over the standard deviation of 7.7, and that turns out to be 0.65. The z-scores in the table are always to 2 decimal places. Okay. So we're finding the probability that z is going to be greater than 0.65. Okay, so we go to our table and we're going to scroll to where we see positive 0.65. So now we're going to look across. So we go 0.6 and look at the top headings, and we see 0.65. So whoa, I went too far here. So it's, if I look at the proper row and proper column heading, that's equal to 0.7422. But that 0.7422 represents the area to the left. I need to find the area to the right. Since the area has to add to 100, normal curve is a density curve, the area has to be 100% or 1. We would go 1 minus 0.7422 in order to get the value greater than that. So we're going to find 1 minus the probability z is less than or equal to 0.65. That's 1 minus 0.7422, and that's equal to 0.2578. So what kind of work would you have to show on my test? Because I did an extra step. You have to show the drawing, right, with the proper shading. You have to show, you don't have to show the formula, but you have to show the substitutions into the formula. You have to show this, and you have to show that. Okay, tomorrow, the next lesson, I'll show you the work expected when you use technology. Okay, let's go on to D. What percentage of runs will give the DeLorean speeds between 64.6 and 87.1? So again, we mark up our diagram. Let me get the pen out. And I want the darker color. So that's 80. And we're now between two values. And now we're going to shade. So now we're looking at between two values. Let me get my drawing tool. So the probability that your data value, your x, is between 64.6 and 87.7. So we're going to have to convert both of those to z-scores. Whoop. So the z of the 64.6 is equal to 64.6 minus 80 over the standard deviation of 7.7, and that gives me a value of -2. And now z is z of 87.7 is 87.7 minus 80 over 7.7 is 1. Now we could have used our empirical rules since these are values on the actual standard deviations, whole numbers, but I'm going to show you you don't have to. You can still use the table. And again, tomorrow I'll show you how to use technology, which is easier, but I will show you that tomorrow. And so our data value is from 64.6 to 87.7. Whoop, I meant to change that to the z-score. So -2, it's a z now because I converted it to 1. Okay, so we go to a table. Let me erase this. Okay, so 1, the value is, hold on, 0.8413. Okay, that's the proportion of the data to the left. And then -2 is 0.0228. So I hope you can see that. Well, how do you find the area in between? Remember, when you're looking at the table, it's always to the area to the left of what the cutoff score is. So how you have to do this is you take the probability that the larger is less than 1 minus the probability you're going to, because that's going to go all the way to the right. In other words, if I shade that value of z is less than 1 is equal to, as I just showed you before, the 0.8413. But that goes too far. I want it to stop at 64.6. So what you do is you subtract out the area to the smaller value, and that's going to be 0.0228, and that's equal to 0.8185. And as a percentage, it would be 81.85%. It will be easier when we use technology, but there's a certain concept I need to get across, which is why I'm showing you by hand on the first day. So we're going to do a problem that's similar. I'd like you to put the video on hold and try it. You're back. Okay, so let's try this. So again, we mark up our diagram. Always try it first yourself. Always diagram and shade. Again, this is like a shaded problem, right? You always shade, and you're always looking in between the two places in this case. So we want to find the probability that our speed for the DeLorean is between 70 and 95. That's not landing on a whole number, so we have to convert it to a z-score. So I'm going to do the 70 first. You're going to round to do 2 decimal places, and that gives you negative 1.30. Now we do 95. So 95 minus 80 over 7.7 to 2 decimal places is 1.95. So you're writing that conversion. So negative 1.3 is less than z is less than 1.95. If you're doing this by hand, again, it will be easier when we start using technology, and on a test you can always use technology. We're going to find the probability z is less than 1.5 minus the probability z is less than negative 1.30. Okay. So we go to the table, and let's do 1.95. So go to the positive values. So 1.9 is this row, and 1.95 is 0.9744. And now we want to subtract out negative 1.30. So negative 1.30 is the 0.0968. And when we do that, we get a value of 0.8776. And as a percentage, it's 87.76%. The last problem I'll have a separate video of. I hope your day is great. See you soon.